So thank you very much. Thanks for the opportunity, inviting us to give these three presentations. So, I've been involved in citizen science projects long before the term citizen science was invented. So was involved with the first bird atlas, described as the biggest biodiversity project ever on the continent of Africa. And citizen scientists then were known as volunteers, and we had something over 5,000 volunteers. And I need to pay a tribute to James Harrison, who was the leader of that project, because he somehow had ideas which were way, way ahead of his time. And so here's my my first picture. I hope you find the stick man suitably disgusting. So when we set up citizen science projects, we have to remember, and this is sort of going back to what Karis was saying, is that we are scientists. We're not trained as sociologists. Yet we actually are, what we are doing is, as Karis is saying, is actually really quite deep sociology. So one of the problems with citizen science, as it is mostly practiced, is that we treat our citizen scientists in the same way as that disgusting picture does, eyes on matchsticks. And so the sociologists who look at everything have looked at citizen science, the citizen science space through their lens, and they say the optics are not good. So they are deeply, deeply critical of citizen science as we mostly do it today. They say it's too top-down, it's too authoritarian, people are told what they have to do, and there's very little consultation with the people who are going to collect the data. And as I say at the bottom there, if words like space and lens and optics don't work for you, then you're a scientist. Those are the words that sociologists tend to use. They have a whole different language. But in reality, the sociologists are right. There are deep fundamental problems with the way citizen science is mostly run throughout the world, not just in Africa. But the sociologists have got their reasoning wrong. So the only way, in fact, to do citizen science projects is to actually have a fixed autocratic protocol that everybody has to adhere to. The idea of bottom-up approaches to citizen science as we want to do it just doesn't work. And so one of the things that we actually are training people in is in the scientific method, the basics of the scientific method. And that is, you have to collect data according to a fixed and rigorous protocol. If you just do it in some sloppy way, the data is not worth anything at all. So the way citizen science is done has to be the way it is done by having leadership that actually decides what's going to be done. But as Karis was putting it, citizen science is actually far more than just the collection of data, and that's where the criticisms by the sociologists are spot on. They've not put their fingers on the right problem; they've put their fingers on a wrong problem. But the criticism is basically that we treat our citizen scientists merely as eyes on matchsticks. They just collect the data for us. And so, as Karis was saying, we have to grasp that citizen science is potentially a pathway to civic awareness. These are really quite fundamental things that we are doing with people. And from civic awareness, it's potentially pathway to democracy. So there are lots and lots of different types of citizen science projects. We know from in our world, we actually aren't doing citizen science. We really are doing citizen biology, but citizen biology just doesn't feel right. There are people who do citizen astronomy and citizen oceanography. In those contexts, it sounds better, but you're just stuck with this word citizen science, which is open to lots of criticism. There are people who say we should be talking about not citizen science, but gosh, where's my tongue? It'll come back to me. So there's the projects that I've been mostly involved in are those projects which use vast numbers of people to collect the data for distribution maps for species atlas projects. Then there are waterbird counting projects, and they've been going on for a long time. Waterbirds are quite easy to count, ducks and things on a lake, a fixed area. So waterbird counting projects are manageable. If you have to count birds in a sort of a forest or something like that, it just becomes really, really difficult to do. Bird ringing is an example of a citizen science project. And bird ringing is a project that requires a huge amount of commitment and skill and learning before you can actually become a bird ringer. So it's a difficult citizen science, difficult project to get into, and there are really very few bird ringers. Then there are projects which potentially look at phenology. When does a plant species flower? When does a bird species migrate? And then in our context, we move away from photos of the working with the animals themselves, but to photographs of nests, things that the animals have built. So there are citizen science projects in astronomy, examining thousands of photographs of stars on a screen. Citizen science projects in oceanography, where people who are on the sea take sea surface temperatures and things like that. And there's a whole lot of potentially citizen sociology, I suppose, that should be called projects. Things like reporting burst water pipes and just generally urban service delivery issues. And we could do pictures of rural architecture or designs for game fences. Or my favorite is pictures of all the different types of gates on farms. There are citizen science projects that deal with illegal logging in tropical forests, that sort of thing. So those are more sociological. But there's a common factor. It's getting more eyes in many different places. And that enables us to collect far more data and in far more places than the official people can achieve. So there we get back to this view of the citizen scientist as the eyes that collect data, and that's what we reduce them to. So, in the practical side, when you're setting up a citizen science project, the first thing that you need is some sort of protocol. But before you can even do that, you need to set yourself some objectives, and the objectives themselves need to be set in the context of what is achievable. So from the science side, when we were setting up the second bird atlas project, the scientists were pressing for the citizen scientists to collect more and more and more data, right down to the sort of question, what brand of toothpaste is that bird using? So protocols are a tension between getting lots of information or just a a little. And the fundamental theorem of citizen science, data volume is inversely proportional to protocol complexity. So I'm more of a mathematical statistician by training than anything else. My world as a student consisted of theorems, and the theorem needs a proof. And the proof of this theorem is just run a citizen science project yourself. And you'll see that as you make it more complex, you get less data in. And that's a major, major issue. So, issue of complexity. Keep the protocol as simple as you can, but make sure you get useful data. It's no use just gathering data and then discover it doesn't answer the questions that you've set yourself. So, so when we're collecting distribution data for an atlas project, basic data we need is the identification, the place, and the date on which the data is kept. It's really, really important, whatever protocol you come up with, is to do extensive trials of your protocol and find out what all the little glitches are. And this, I repeat, this complexity issue of keep it simple. And as soon as people have to count something, then participation falls away. We found that with all our projects. So with an Atlas project, it just becomes presence, absence. It doesn't matter how many are there, animals of the species are there, you just mark it as present. And if you realize that that's a huge shortcoming in the data. But as soon as you ask people to count, if you get hardly any data in, that's one of the key things in citizen science, is keep it simple. You have to think about the skills that your citizen scientists need. So there are lots, comparatively lots. People who can identify birds, relatively few, can do dragonflies, damselflies, or butterflies, and things like that. And hardly anybody can ID millipedes and dung beetles. You have to think about the equipment that people will need, things like binoculars, cameras, field guides, GPS, transport, internet connectivity. All these things are going to influence the amount of data you're going to be able to collect. So there's a few little practical tips that come in the next few slides. So the temptation is always to have some sort of competition. This must increase data volumes, you think, and it does. But sadly, as soon as we have a leaderboard, we've discovered that there are people out there, even amongst our citizen scientists, who cannot bear not to be at the top of the leaderboard. And they do terrible things to get there. So you don't want any fake data in your project database. What does work, though, are team events, and this is very much creating a community. So things like how many records can we, as a team, collect in a week? So we used to have, and we should still have, Shoot the Dragons weeks for Odonata Map, the atlas of dragonflies and damselflies that Ryan will be telling about next. Those things help in promoting the project and in creating awareness of the project, the kind of awareness that Karis was talking about. And it's just worth noting on the side that the value of each citizen scientist to a project is not measured simply by the total number of records they submit. Some of the most amazing information comes from the people who only submit a handful of data. They might have a lot more data at their disposal, but they just don't submit it. They just submit handfuls of really interesting records. And so it's very easy when you actually are dealing with citizen scientists, is just to focus on the people who submitted lots of records. One has to realize that everybody is valuable in their contribution. So this is just eyes on matchsticks type contribution. Then there's a fairly new concept called gamification. So just in the same way as citizen science is not a great word. I guess the word I was trying to think about. Somebody's proposing that citizen science should be called tracker science. But the reality is we're stuck with the word citizen science. We're not going to change it. And we're not going to change the word gamification, which sounds like it's making things into games. So gamification means something like built-in motivation in your projects. So if you choose which airline you're going to fly on, it's not a game in the sense of a sport, but the airline's frequent flyer programs are one of the earliest forms of gamification. Gamification before the word gamification was invented. So basically with frequent flyer programs, if you buy, say, 7 flights, you get the 8th flight free. And now you've done 7 flights and you're choosing your airline for the 8th flight. And even though your frequent flyer airline's flight might be a lot more expensive than an alternative, you still go with that airline. And that's gamification. It's built-in motivation to stick loyal to one airline. So that's an example of gamification, which is not anything like a game in the normal sense of the word. So within the bird atlas, we had the story about the wife of one of our atlases, a citizen scientist, and the wife was horrified that her husband, the citizen scientist, was planning the family holiday using the coverage map for the project. So the coverage map with its grid system is a very powerful tool in gamification. So you get the guys, the citizen scientists, and you get them looking at this map, and they look to see that there's a gap somewhere, and they work out how on earth they're going to manage to fill that gap. So that's gamification. If you look at the area around Johannesburg, around Gauteng, yeah, you see it's a square, and that was a most amazing gamification project. Is that group of people decided that they were going to turn that whole area green. So to get this light green color, you have to have 4 to 6 checklists of species. To get it to be dark green, you have to have at least 10 checklists. And so they had this competition going to actually turn Greater Gauteng green. And so they managed that. And that was a form of gamification. So the coverage map is a hugely effective tool in gamification. So this was the map from 2015. In 2021, this project still continues. This is what it looks like. So the Gauteng square has had a project to turn it blue, which needs 11 checklists. Green was 7, dark green was 7 checklists. So up here across, I suppose that's called Gordonia, there was a citizen scientist who retired early, and he spent a couple of years turning every accessible grid cell in that region to green, to have 4 checklists. And those are amazing contributions, and you'll see other little sections. This was one individual who decided to turn that area green. There's another block there. So this coverage map actually is a hugely successful tool in actually getting people to cover areas. And a lot of today's citizen science projects just collect data without any underlying grid. And what they are unable to do is actually to say how good coverage is, and they lack this tool which actually helps coverage. So there must be other gamification things as well that can be built into the system, but this is the one that we found to be exceptionally effective. And now I'm starting to introduce what Ryan will be telling us about. And so we have this incredibly important concept in citizen science of the hill. And on the right-hand side is this axis called influence, and this big pile of data that you collect has absolutely zilch influence whatsoever. So an awful lot of projects, all they're trying to do is to get a big accumulation of data, and that's totally useless. Totally useless. The database means nothing. So you have to push it up this hill, and the first thing you have to do is turn it into information by summarizing it. So these are things like distribution maps, any sort of interim product that you can produce, summary of the information, and that's part of influence. And then you've got to take those maps and tables and histograms and interpret them, turn them into papers, into theses, into policy documents, and that becomes a narrative. And then you finally move into to use the term that the sociologists use, policy space, and then your project really has influence. So this is influence on the sort of sciencey side. It's not the kind of influence that Karis was telling us about, but it's influence on the participants themselves. So collecting the data actually is important from the point of view of actually changing the behavior of the participants, and actually, in a big sense, making people more receptive to the policy stuff at the top of the hill. So I think this is a crucially important diagram for actually understanding what we're trying to do, and we are just delighted that the Freshwater Research Centre has helped us get the Odonata map data up this hill into policy space, and that's what Ryan will be talking about. So we don't only have to have policy at the top of the hill. There are also things like education, and we've talked about civic awareness and democracy. So when textbooks are written across Africa, and the authors are desperate for examples to put in those textbooks, it's sad how many of those examples come from Europe and North America. And so we should be actually, one of the things we should be doing with our projects is actually opening them up to the people who have to write textbooks, and actually somehow making our data relevant to them, in the same way as we try and make our data relevant in the policy space. And there must be many other areas in which we could have influence through our projects. So now I'm back on Karis's territory. Religious terms again: citizen science, profit or loss, and our general description, understanding of the job of a prophet is to foretell the future, but that is completely incorrect. The job of the prophet is to issue warnings to your community that if you carry on doing business as usual, the consequences are serious. And as biodiversity scientists, we know consequences of business as usual are the loss of ecosystem services. It's all doom and gloom, as much as the prophets of the Old Testament issuing doom and gloom. So we have a responsibility as leaders of citizen science projects to enable our citizen scientists to be prophets for biodiversity in their communities. So some people might prefer the term ambassadors to prophets. So ambassadors for biodiversity is just the same concept, carrying this message into their communities. And that's what Chorus was telling us about. And how do we do this? The most important thing for keeping citizen scientists loyal to a project is to provide feedback. And I think, I look at the projects I run, and I think we are actually failing in actually providing as much feedback as we ought to be doing. Social media are a great resource. A Facebook group is somewhere where project participants can post as well, tell their stories about their projects, whereas a Facebook page is only accessible to the project coordinators. Blogs are also a great source, a great way to communicate with people. So some proportion of what goes, of the content of these things needs to be information which citizen scientists can tell their families and colleagues and friends. So when one of your citizen scientists goes to a party and somebody is making polite conversation with them and says, "What were you doing this morning?" then you can give him or her various answers. And answer A was that I was having fun doing citizen science. Or answer B is Odonata Map needs our data, and I was busy with data for them. Or you can actually give an answer C that explains why you were participating in the project, and give examples of how the data that you've collected is actually going to feed into policy and improve biodiversity conservation, improve ecosystem services. So that's what you need to be feeding back to your citizen scientists, is real solid information relating to participation in the project. So I'm going to talk a little bit about the virtual museum. So over on the left is part of the reptile collection of the museum in Paris, snakes in alcohol. And over on the right is the collection of Cape cobras, or part of the collection of Cape cobras in the virtual museum. So if you're a mathematician, you have real numbers and virtual numbers. If you are a physicist, you have real images and virtual images. So on the left, you actually have the real animals, and on the right, you just have pictures of the animals. So there are benefits and losses. I'm not decrying museums. You cannot get a DNA sample from a photograph, but there are lots of other things that you can actually get from the photograph. Generally speaking, you can get the identification, and of course, when the snake is in the bottle, it loses its context completely. Very often, the virtual museum photographs actually show a species in its habitat. So in terms of skills, the virtual museum is basically at the bottom of the pack in terms of citizen science projects. The protocol is essentially just snap it and map it. Photographs are uploaded to a website and are georeferenced, either from having written down the coordinates while you've been collecting the data from your GPS, some other way of collecting that data, or within the virtual museum website, you can click on the Google map where you were, and that records the coordinates. You don't need to identify it. There's a background, there's a team of experts who actually do their best to do the identification. With one exception, the photographs in the virtual museum are of the biodiversity itself, the bird, whatever it is, orchid that's being photographed. The exception, as I hinted earlier, is a project called Phone, Photos of Weaver Nests. And that was a great piece of lateral thinking on Dieter Schedlaeus's behalf. It was a departure from the concept of just taking photos of the biodiversity itself. So we could do gate map with all the different mechanisms for opening farm gates, or we could do photos, seasonal photos of rivers. And if there are projects which people can think of, this system might well be able to accommodate it without much modification. So, in a nutshell, I'm repeating what Cara says. We need to do citizen science and not citizen science. So we need to get that balance between the two words right. So there's this picture on the right-hand side, the stick man with just an eye should fill us with the revulsion it deserves. If that's our way of doing citizen science, then we shouldn't be doing citizen science. We have to treat our citizens, scientists as real people. And as Cara says, this is an incredibly important way of actually changing grassroots attitudes to biodiversity. Keep the protocol simple. And remember that you are not simply building the biggest database of its kind on the planet. The database itself has no influence. And your citizen scientists are actually busting a gut to collect data for you. They're spending time and money. So you need to push the data up the slope of influence. And that ultimately is what the JRS Biodiversity JRS Biodiversity Institute is all about. It's actually getting data from just these big piles of data up the hill to where they have influence. And we need to include the sociological objectives in our projects right from the start. So that's what I wanted to say. So thank you very much. Thanks, Helen. Thank you.